I welcome you all students. During this class, we will uh, solve some of the problems in numericals to understand the basic concept of fluid dynamics. And now we are at a sixth problem to understand to use different types of the techniques to solve some of the basic quantities, physical quantities. This time we are asked to calculate uh, speed of efflux. So here it is, calculate the speed of the efflux kerosene oil from narrow speed from a narrow hole tank in which pressure is 4 atmospheric atm and the density of the kerosene oil is 0.72 grams per centimeter cube and one atom is 1.03 into 10 raised to the power 5 Pascal. So here it is 4 atm atmosphere is equal to 4 multiplied by 1.03 into 10 raised to the power 5 Pascal. So for 5 it will be 4.12 multiplied 10 raised to the power 5 Pascal. So density of kerosene oil is 0.72 grams per centimeter cube. So if you have to calculate or convert it into kgs per meter cube, so this is the condition. So this is the procedure to multiply with 10 raised to the power minus 3 and divide with 10 raised to the power minus 2 and scale. So because you are converting into kgs into grams into kgs and meters centimeter to meter, so that's why you're taking its cube. So if you look at, you are asked to calculate the speed of the efflux. This was the only conversion of the units. Then what about to calculate the speed? Faras's theorem you have already done. That is V is equal to root 2 GH. And you know that to calculate the pressure, that is rho GH. So here it is. If you're basically, you don't know the value of the height. It is not given. So how will you calculate? Density is given. G is constant. So pressure is given. So how will you calculate then height? You will use this formula to calculate height by using the given values. You have calculated height. And after calculation of the height, you will put in the value to calculate the speed. Here it is. To calculate the speed, it is root 2g, and this one is h. And you place the values of the h in this formula. Which formula? In this formula. After putting the value of the h, you have calculated the speed, and after simplification, you know this g is cancelled with this g, then it's rho 2p. Here it is formula, and after putting the values, given values, you are getting the speed, and the speed of the flux is how much? 33.8 meter per second. And what was required? You were asked to calculate the speed of a flux. The flux of the kerosene oil from a narrow tube, narrow hole of a tank in which the pressure is 4 atmosphere atm. Density of the kerosene oil is 0.72 grams per centimeter cube. So by using all these values, you reached up to this point, and before you reach up to this point, you must know there was h involved and height is value is not given. We will use our given sources, and by searching from those sources, you will calculate the height by using this formula, and you will put in this formula, and then you will be able to calculate the required speed of the flux. Thank you very much for your attention.